Thank you all for coming tonight. Hope you have a great time. It's going to be a splendid talk. Next week, on August 24th, Laura Wyatt and Adam Gundlach from the Lakeshore Nature Preserve, which is part of the facilities and planning and management, FP&M, will be here to talk about the Lakeshore Nature Preserve, UW-Madison's largest outdoor classroom on campus. Every one of those things has to be in that title, because if I don't say on campus, who gives me a call? The Arboretum. And then who gives me a call? The Agricultural Research Station. It is amazing. We have about a 930-acre central campus here, and a little over 300 of those acres is composed of the Lakeshore Nature Preserve. And it's a splendid thing. You get to hear about that next week on the 24th. On the 31st, James Edward Mills, who's with the Nelson Institute and the Joy Trip Project, will be here to talk about the Adventure Gap, changing the face of the outdoors. On September 7th, I don't have a speaker yet. On September 14th, Anna Caroline Paiva Gandara will be here from the Department of Genetics here to talk about their work. And then Michael Menon from the Nelson Institute and the State Department of Aviation will be here to talk about wildlife and aviation. Yeah. And on the 28th, Lindsay Snyder, who's a veterinarian and an anesthesiologist, will be here to talk about her clinical work at the School of Veterinary Medicine on anesthesiology of animals, including, what do you call that thing when you rub the needles? Acupuncture. Like, wow, I didn't know. So now you got to stand there.
Okay.
Now I got to stand here.
Okay.
I take my glasses off so I look more intelligent. Marginally.
Sure.
Thank you. Welcome everybody to Wednesday Night at the Lab. I'm Tom Zinnan. I work here at the UW-Madison Biotechnology Center. I also work for the Division of Extension Wisconsin 4-H. And on behalf of those folks and our other co-organizers, PBS Wisconsin, the Wisconsin Alumni Association, and the UW-Madison Science Alliance, thanks again for coming to Wednesday Night at the Lab. We do this every Wednesday night, 50 times a year. Tonight, it's my pleasure, a great pleasure, to welcome back to Wednesday Night at the Lab, Matthew Lazzara. In December of 2005, he was at a table here when we did the first 4 pilots of Wednesday Night at the Lab. So that's pretty amazing to have you back. He also came back in 2014 to give us an update on his work. I'm very envious about the number of times he has been to Antarctica, which is at least 10.
10 times.
You're going to talk with us about observing the extremes of Antarctic weather and climate. Now I get to ask you the 5 questions. Matthew, where were you born?
Massachusetts.
Where in Massachusetts?
Norwood, Massachusetts.
Where is Norwood?
Halfway between Boston and Providence, Rhode Island, roughly.
Okay. I'm saying hi to my mother-in-law because
Yeah.
she's probably watching, and she
Yeah.
grew up in Pittsfield and lived in
That's right.
North Adams.
There you go.
Hi, Claire. And then where'd you go for high school?
Place in Rentham, Massachusetts.
Rentham.
Yeah.
All right. And then where'd you go for your undergrad and what did you study?
I went to a place called Linden State College. Today it's known as Northern Vermont University at Linden, and I studied meteorology.
Very good. And where'd you go for your advanced degrees and what did you study?
I came to the University of Wisconsin-Madison to study my advanced degrees. While I was employed here, I did my master's in atmospheric sciences and my PhD in atmospheric and oceanic sciences.
Great. And then you also work for Madison College?
That is correct. I'm faculty and department chair for physical sciences at Madison College.
And then you work also here for the space science and engineering.
That is correct. I'm senior scientist here on campus.
This is fantastic. I'm looking forward to hearing about the extremes of Antarctic weather and climate. I'm going to go in the back, shut the door, and make sure the heat is on. Would you join me in welcoming Matthew Lazzara back to Wednesday Night at the Lab?
Thank you, everyone. It's a pleasure to be back here and on a warm summer day, talk about something cool, Antarctica. At least I think it's cool. And so, as Tom noted, I have the luxury of being a researcher here at the university, and I get to be in the classroom at Madison College. And so we're going to be talking about the work I get to do really at both institutions, and it's a wonderful partnership, and I'm thrilled with the support I get from both places. And we'll have lots of pretty pictures. Oh, wait a minute, this is just a weather station. Sometimes Antarctica, this is all it is. I want to note first thing right off the bat that what you're going to see here is not just my work, but really a team of people. I'm sorry they're not all here tonight. Some of them may be online watching. Some of them are preparing to go to Antarctica as we speak. And so it really takes a group. And so this is a group here at both here at the university and a few at Madison College that really make the work that you're going to see today come to life. So we'll give you a bit of a background. We'll tell you a little bit about these things called automatic weather stations that we have in Antarctica. A little bit of what's like to be there, doing some field work. And then, yes, what you've come to see. Let's talk about the extremes of the Antarctic, right? Let's find out what it's like there. There's been some interesting events in the past year to talk about. One of them actually is an interesting solar eclipse. We'll talk a little bit about observing that with some weather stations. And in addition to scenes in the field, well, maybe we'll end with talking about some of the interesting people you meet along the way. And of course, we do need to thank a few folks for making this all possible. I'm going to start with a thank you here. I didn't start this project alone. It began really with Dr. Charles Stearns, the late Professor Stearns here at the university, who had a very long career and distinguished career at the university. He started his work in the Antarctic late in his career. He was over the age of 57 when he got asked to get involved in Antarctica fresh. He was famous for building weather stations here in Wisconsin before that, studying air pollution and studying how the atmosphere behaves out here just above the lake in the wintertime. And so getting the chance to do this later in career, he really fell in love with it. And he did some things that were, at the time, very groundbreaking. One of the first to really, share data openly, just give it away. People thought he was crazy doing it. And he really fostered a lot of collaboration doing that. And it was a really big thing. And now it's become an expectation. We all do it now in the community. So welcome to the ice. It's what it's like when you fly on down. We go with a variety of folks. This is one of the more common ways that we might go is with the 109th Air Guard out of New York State. This is an LC-130 aircraft. And it's the L, by the way, is for skis. You can actually see the skis on the bottom of the plane. By the way, the view from where I was looking is this. This is Mount Erebus. This is the southernmost active volcano in the world. Doesn't this sound like a great place to have a research station? It's fabulous, right? And this is out on there's an airfield that's on the semi-permanent ice out in front of the station. It's about 10, 15 kilometers away. And so folks who are studying volcanology love it, but it is an interesting place. It's a big station, the U.S. main station. This is McMurdo Station. This is the largest station on the continent. So this is like the New York City of Antarctica. It holds maybe, 1,200 people when it's really, really, really got a large population. Winter over is significantly smaller, a few hundred at less. And so that's where it is. In fact, one of the things that's interesting about this location is the southernmost place in the world you can sail ship. And you can see here, we do sail resupply vessel to maintain the supplies we need to do our work and to be there at the station. So this place is called Winter Quarters Bay. And by the way, there's a little history here. You'll see here a little wooden hut off to the side of the screen. That's Scott's hut, the famous Robert Falcon Scott, who built that at the turn of the 1900s, right? When the heroic era of exploring Antarctica. It's still there. Not much of it's changed. Everything is in it as he left it. And you can see there's a cross there going to one of his shipmates on the Discovery ship. A gentleman by the name of George Vince, unfortunately, slipped off that slope here and died and drowned. And so the cross, by the way, was erected in 1902, and it's still there. Wooden cross, still in good shape. We here at the University of Wisconsin have been building and maintaining a network of weather stations in Antarctica for 42 years. And we've had several generations of these stations that you see here. And we've been trying really hard to keep that network up and running. It benefits not just research we do, but it's used by the whole Antarctic community, whether you're weather forecasting, if you're doing weather research, climate studies, or even if you're studying penguins. Those folks use this data. And so it's really a community resource for everyone. These weather stations do the same thing you might do at a weather station at your house. Measure the temperature, pressure, wind speed and direction, relative humidity. It just has to do with one of the harshest continents in the world. And so we try very hard to assemble them in a way that can stand up to that harsh environment. And so we've been building automatic weather stations. I'm going to talk here in a few slides about a new project we've been developing, a polar climate and weather station, which has a lot of some of the learned features that we've had from prior knowledge over the years of how to best run a weather station in the Antarctic. Here's what they look like. We have a masted tower, and then on the towers where we put the sensors, we may have an arm that goes off to the side so we can measure a few things. We've started to expand, trying to measure the snow accumulating next to the station or the incoming sunshine. And that's kind of what it's like when you're here. And as you can see, it's very, some spots in the Antarctic are very unremarkable. It's amazing how we get out there and it's nothing but snow upon snow for miles, as you can see. How do we power these things? How do we have them run all by themselves for a long time? Because I don't always get out to visit these sites very much. Some sites don't get visited. Some do every year, but a lot don't get visited for 2, 3, 5 years. How are we getting them to run that long? Well, it's a battery and solar panel system is what we're doing today. We're very low power in our usage. We're one of the lowest powered autonomous devices on the continent that runs all the time. I always love asking this when I go visit school children, and I ask, okay, who left a light on at home today? Did anyone leave a light on at home today here in the audience? Oh, someone's admitted to it. It's always someone. If you do that for 20 days of the year, that 20 days will power one of my weather stations for a whole year. So it's very low power usage. At one time, back in the beginning of this network, before my time in Dr. Stearns' era, we actually used radioisotope thermoelectric generators. If anyone doesn't recognize what that is, that's basically a mini nuclear device. It was lovely, provided a lot of constant power, but the United States made a decision in the late 80s, early 90s to remove nuclear devices from the continent, and so we have them no longer use that kind of power system. And we do very well going to solar. It's gone very well for us. The communications relay of the data was another special thing that was done with this project. When the engineers who built these original weather stations back in the 70s at Stanford University, they discovered there was a great system that had just come online called the Argos system. So weather satellites that fly overhead, polar orbits right over here in Wisconsin even. Those satellites are contained on board a communication system that listen to our weather stations and relay the data back to us. So most of our network uses that, and we've been using that for the majority of the last 40 years. We have started to play with a lot of modern communication systems, not that that one isn't modernized, it has been, but if you might think of a satellite phone, also known as Iridium, we've been using that technology as well. There are pros and cons to each of them, and we're happy that we have the options to use them. One of the things I've been really excited to spearhead in a collaborative effort between Madison College and here at the University of Wisconsin has been building what is known as the Madison AWS or Madison PCWS. It's a polar climate and weather station. It's a brand new electronics core for a weather station. The early ones that we built here in the 1980s were home built. We built them here on campus. Well, you can't buy a lot of that equipment anymore from the 1980s. Our original weather stations used the same technology that was in the Pioneer spacecraft. Those are the ones that flew before Voyager. They were military spec for extremely cold temperatures. You can't buy that equipment off the shelf anymore. It doesn't exist. And if you had it manufactured, it would cost a fortune. So today, we use a lot of commercial off-the-shelf systems, and they're okay. They do well for us, but it's a black box. I don't know what's going on inside. And so I had a couple of experiences where our older systems, we can actually pull them out of the field, put them on the bench here at Wisconsin, and test them down to the resistor and figure out what's going on with them, if there's anything wrong, and make sure the data we get back is as accurate as possible. And we actually did a paper on some warming in West Antarctica that really made that such an impression upon me. I'm like, we must get back to building our own equipment. That way we know down to the resistor what's going on. And so this is the first demo system that we've built. The latest demonstration boards are actually coming this next week. We're going to have the end of this project, this research and development project, finally develop a board that we think will allow us to give it a try in the Antarctic. It's great because it was built working with students. We've been enjoying taking advantage of the experience here at the university, working with the tech students at the college to give them an experience working on building an actual electronics core. So it's very exciting. Oops. Another thing that we've been doing the last few years is we've been building weather stations that are a little taller than the ones I was just showing you. Most of our weather stations are about 12, 15 feet tall. Mostly they're kept that short in the Antarctic because it kind of is hard to keep a taller station, staying up in the wind. It's really a challenge, but we've actually started to do this in a few places. We've built some tall towers. And if you may ask the question, how tall are they? Thank you very much. Well done. 100 feet. So we've had this one you see on pictured here. It's been installed now for, I think it's a little over 8-9 years, and we've not had it fall over at all. I'm really excited. It's one of the few towers in Antarctica that has stayed. We've been able to keep without having any bending or falling over for this entire period. It's really exciting to me. A lot of other nations have tried to do this and they've had catastrophic collapse. And so I'm really glad we've done that. And it's providing us measurements through the lowest part of the atmosphere so we can understand how it behaves. It is my hope this year we will finally get to do our second tall tower. We've been planning it for quite some time, and the pandemic has definitely delayed that work. And so we're hopeful that we'll have that installed at another location in the Antarctic as well. This map here, and this is one of the fun things I kind of do, I love connecting with the Antarctic community internationally, worldwide. One of the things that's I think very exciting about working in Antarctica is I get to work with everybody. We don't have a lot of hangups, concerns, worries, as we often sometimes do here in the mid-latitudes. When it comes to Antarctica, everyone is very open, very sharing, very congenial. And this is one of those products where everyone's very happy to tell me, these are the automatic weather stations running in the Antarctic for any nation, including the ones that are a part of my network. And when you look at this, I know it seems like there's so many stations. Doesn't it look like there's just tons? Please don't be fooled. If we were to show you to scale the different, lettering and the actual label spots, there are massive gaps in this network, huge pieces of real estate that are unobserved. And so it kind of looks really good. I want to show you though, it's just the Wisconsin part of the network. And this is it here. It's roughly a third of all automatic weather stations running in the Antarctic, perhaps a little more. So that's quite a few, if you take a look at the two combined here, if you go back and forth a bit. And I don't do them all alone. We have really great relationships with several nations to collaborate, who can put out some of the weather stations in places that we don't go or don't have the opportunity to go. And that's what makes this network work out so well. By the way, if you're wondering, how big is this piece of real estate you're instrumenting? It's the size of the continental United States and Mexico combined. So this is a fair piece of real estate that we're measuring and trying to capture observations across. All right, what are you doing when you're there? Come on, you're making it look good. Well, when we're there, one of the biggest things we do is that it snows a little bit slowly over time and buries the stations. So if we don't visit them soon enough, they'll be gone. So we have to often go and dig them up, put on a new tower, which already took place before this video began, and then reinstall the equipment. And that's what you're seeing take place here. So this was put together by a former member of my team, Carol Costanza. This is Lee Wellhouse, who will be deploying from my team to Antarctica a little later on this year. And you can see them spending time here, putting the instrumentation back on this particular weather station. And so this is the kind of work that we do when we're down there. Yes, notice the weather's gorgeous. We don't really want to be out doing this in terrible weather. It's miserable. It's not safe. Not only just not safe to be doing the work out there, but traveling out it. And so we always strive to be out there in better weather as much as we can, because it's just too dangerous. So anyways, that gives you a sense of what it's like when we're out there. We use all kinds of transportation methods. So you saw the snow machines in the prior pictures, which, by the way, we also did fly in, I think, to get to that location. We've taken track vehicles like this. And I know I have a big smile on my face, don't I? I shouldn't be that excited, and I wasn't, because when we got out of we were only part way to this weather station, and when we got out of the track vehicles, I was up to my hip in snow. It was so soft. We were not going to have enough fuel to get to the location. We had to turn around. I felt kind of badly. So we had to use a different method to get to this weather station. It was just too much fresh snow. It was just amazing. We run into problems at the weather station sites. And here's an example. Inside these frosted in areas is where we keep our temperature probes. So when you take a look at this device here, we put up a shield here so that the sun doesn't shine directly on the temperature sensor. Our temperature sensors are different kinds. This is an example of one kind. It's a platinum resistance thermometer. It's a lovely device. Platinum's lovely because it's very stable, very well predictable of what we know we're going to get for a measurement out of it. Works great in cold. So this is what's inside of here pretty much. But if you shine the sun directly on it, you get erroneous readings. So this protects it from getting a bad reading. However, as you can see here, they can get frosted. That ruins the measurement. Or sometimes we end up having really bad situations take place. And as you can see here in this particular one, something hit this shield. You can see it's all cracked and broken. Sometimes we get some very definitely high winds, and you either get pieces of ice, actually lofted rocks in the air, and then they damage the equipment. So that can be really rough. This is a bad day. Doesn't it look pretty? It looks pretty. This is rime ice. So this is a location, it's a place called Minna Bluff. We'll talk more about it in a minute, where you have cloud mass going by, liquid cloud. So it's cloud droplets, they're super cooled. And that means the temperatures are below freezing, but the cloud itself, the content of the cloud is all liquid droplets. And then when it hits the tower, at that point, it freezes on contact and it creates rime ice. It looks lovely. This happens a lot of places in the world. I think a famous place here in the United States, Mount Washington, New Hampshire, they have lots of this. In fact, they struggle really hard to get rime ice off their sensors to get high wind measurements. And I have the same problem here. So we go and we chip off the ice. And of course, now I'm happy because this is what the station should look like. When you get all that ice off, you can say, aha, there's the weather station. I see it now. This is a bad day too. This is the same location. The entire top of the weather station blew off. So the vibration of the wind at this location was so much, it enabled to have a lot of the actual nuts and bolts back off from each other, but it also then lifted it off the tower, right? It actually has to come off the attachments at the top of the tower and then get blown aside. What's interesting is the gear we used for this is such high quality. We were able to reuse it. We didn't have to like re-engineer it or get it repaired. It was still in good shape, despite having that horrific blowing off scenario take place. So Antarctica can be indeed a very harsh climate. So there are a lot of other challenges to field work. It's the weather itself. To give you an example, here's that high-speed wind device, by the way. Some of the wind speed devices we use are big, heavy-duty things. This one here is a nice fin on it. This is what's measuring wind directions for us, like a nice high wind speed ones. And some of these others you've seen, the ones with cups on it, to get you actual wind speed. And it's a bad day when you go back and see this. What's missing? The top, it's all gone. It's sheared off completely. And the gentleman who builds these out of his garage in Seattle, Washington, and he does a lovely job, by the way. He builds these for like the military, ski areas and us, and we're thrilled he does it. This is a really high quality device, but even Antarctica has some really harsh moments. Sometimes challenges for us are like you see here on the screen. This is a location that's melting. So we've put the station in, it's gotten melty, and it's tipping over. We can't have it anchored in enough to not have it tip over. We finally had to abandon this location. We couldn't stay there and keep measuring as much as we would have liked to. There are a lot of other challenges. The weather itself is bad, so you wait 30 days to get 3 days worth of work done. That's frustrating. Or in case, 3 years to get 2 new weather stations installed. So a lot of patience is needed, given that you have very limited resources, there's limited aircraft time, limited capabilities, and you are competing with other science groups. And so we want to be very respectful of that and do the best that we can with the resources we're issued. And of course, there's always challenges back here, and even here doing our work. There's data processing to do and quality control of the data to make sure it's the best thing that we can provide to people. And so there's a lot to it. And here you can actually see, by the way, this is the original Wisconsin 2B home-built electronics that we used many, many years for the 1980s and 90s. Some of these, by the way, are still running in Antarctica 42 years later. We still use this gear because it's good, it works nice. Let's talk some science for a few. One thing I wanted to briefly talk a little bit about is people don't always think of Antarctica as having seasons, right? Isn't it always cold there? Isn't it always winter there? Well, I think it really has 5 seasons, and we've been noticing this more and more. This is one location in Antarctica called Marble Point. We've had a weather station there for the entire time we've been in Antarctica, so that's a 42-year record. This is I think a 40-year climatology. And there are 2 months when it's really winter. Excuse me, not winter, it's really summer. December and January, right? So December, January, that's our 2 months of summertime weather. Temperatures at this location, they're not too shabby, -2, -3, -4 Celsius, right? So that's what we're getting into the 20-degree weather, maybe 30-degree weather. Fahrenheit, that's not too shabby. That's good weather. And it's one of the few places in Antarctica that melts out, right? The snow around the station melts away. Then there are 2 seasons where we get fall and spring. So we'll have a couple of period time for fall, February, March. And then right now, we're getting out of a winter time at the moment. We'll talk in a minute, but spring is coming up, right? October, November is spring. So you see these big changes in temperature at this location, right? That's what's highlighted here in the red. And then last but not least, winter. Notice the temperatures just bottom out here at this location in winter. It gets quite cold. But you'll also notice that's not a flat bottom to that. The temperatures don't fall once it gets to April and stay flat cold until September. You'll notice the first 3 months, it's a little warmer, and then the last 3 months of winter are a little colder. We've seen this in so many places in Antarctica. It's really happening there. And they get this split winter. They have a winter 1 and a winter 2 part of their season. So I believe it's really a 5-season place. So let's talk some extremes, shall we? This is one of our other interesting weather station sites on rock, like Marble Point. This is on a place in West Antarctica, really challenged to get to. So there's one of the smaller Twin Otter planes. We go to visit it and go do the servicing work on it. Lowest temperature we've recorded, 120 below. Now, it's not the world record temperature. We'll talk about that in a minute. Back in the 1980s. So we haven't got colder yet. It's really tough getting a cold temperature in a warming world. I'm trying. I keep hoping. High temperature for the entire network. 2 places have a tie for this location. Bonaparte Point, which is on the peninsula, and a place called D10, which is on the Delhi coast. 53. Did anyone expect hearing about 53-degree temperature Fahrenheit in Antarctica? No one probably did, but it does get that warm. And those are recent, right? The 2010. Windiest place on average is a place called Cape Denison. The Mawson's Hut Foundation keeps a historic hut maintained there, where Sir Douglas Mawson, another one of those explorers from the heroic era, had built a hut. The hut's still there from the early 1900s, and it's an extremely windy place. Winds average 40 to 60 miles per hour over a month. That's really high, to have your average wind speed be that high. Most wind speed is that Minna Bluff location. 137 miles an hour. That's category 2 hurricane, folks. Okay, that does pretty well for us. And we might have some other places that are higher. We're still investigating, but that's just an amazingly fast wind. Oof. Okay, let's talk a little bit about those warm temperatures. Group of us across the world, scientists got together with the World Meteorological Organization to discuss what is the warmest temperature Antarctica's ever had. Antarctica in its area is usually considered everywhere south of 60 degrees latitude. So that's the circle you see on the screen here. When we did our investigation, we discovered that, yes, indeed, there's an island south of that location. It's called Sydney Research Station. United Kingdom operates it. it has the warmest temperature ever recorded there, 67 Fahrenheit. Okay, fair enough. That might make sense. What about something touching the continent of Antarctica, right? Well, if you have to have it in the continuous part of Antarctica, in 2015, an Argentine research base, Esperanza, has broken that record, 63.5 degrees Fahrenheit. So that was the reason for doing the study, because they reported it and they thought it was a big deal. And there's been other challenges. Other groups have thought they reported higher temperatures, but so far this stands in all the research that's been done. One thing that impressed me, though, is the group of scientists, and I didn't ask for this, really, trust me, I didn't ask. Someone said, hey, a lot of Antarctica is above 2.5 kilometers high. So you'll see this little blue line on the inside of the Antarctic, just inside the shore a bit. All of that part of Antarctica that's outlined in that blue, and you can just barely see it kind of outlined here. That's where it's above 2.5 kilometers. So the question was asked, what's the highest temperature inside that elevation, since so much of the continent is that tall? Antarctica is one of the tallest continents in the world on average. And it turns out it's one of our weather stations. I was amazed to find this out. It turns out to be a weather station called D80 that we operate jointly with France. It's since been moved. It's no longer at this location. It moved to a new place called D85. It's in the same vicinity. And it had a temperature, it was 19 Fahrenheit. I was just amazed. And so we're in the record books with an official record temperature. By the way, okay, let's talk. What is the cold? You'll notice this little blue dot here. It's almost in the right location for the coldest temperature on the planet. The Russians recorded that, Soviet Union recorded that on Vostok Station in 1983 at 128.6 Fahrenheit below. So that's the record that we're all trying to beat. So there's your extremes of this location. It's really amazing what you can get. All right, how's it doing for change? Are we seeing warming? Are we seeing cooling? Last time I came to this forum and talked, we had just done some studies about, or we're just in the middle of some studies about South Pole Station. And we really couldn't prove any warming. And if you look at this record, yeah, I don't really see much. And we didn't, because that record I published out here at about 2010, 11. And then, of course, 10 years later, a colleague of mine said, oh, it's warming. Yes, it is, because when you add 10 more year data, it's now gone up. It's been going up about a degree per decade Fahrenheit at South Pole Station. That's tremendous. That's a lot of warm in such a short time. So you can literally see the variability has changed. It's kind of going up and down a lot, but it's now hooked, and we're seeing the temperatures warm there, which is really something. This past, not this year, this is back in 2021. South Pole Station, as you can see here, when you look at the winter time. So this is April to September, right? Remember, we're talking about winters. Just looking at their winter time, the temperatures averaged through the winter used to be, 1987 was their coldest, 60 below. But look out here, 2021, South Pole Station had its coldest winter ever at minus 61. And so that's interesting. It's not that we're not still seeing extremes of cold take place. It's just this is rare, right, compared to some of the warming I've been showing you. So we'll start. It's not that we won't still see cold happen. It's just interesting that it pops up with, notice, very high variability in the values here. They yo-yo around a lot. This past year, this is what one of my weather, by the way, when I look at my weather station data, it looks like this to me. The top line is temperatures, and the pressures, and the yellow, and the arrows on the bottom are wind speed. And this is several days of data. And I didn't really think much of this. This is at a place we called Dome Concordia or Dome C. It used to be known as Dome Charlie when the United States went there. Now the French and Italians have a station at this location. And then I looked at the temperature scale. Oh, wow. If you look at what happened in March at this location, this is, by the way, the French put this together. And I'm collaborating with, I think there's about 30 of the scientists around the world that are collaborating on this event. This is the temperature behavior on average at this location. All the black lines are the actual values through all the years since about 1990. And the green line is the averages. The yellow line is what's been happening in 2022. And look what March 18 did. That's like way out of the normal. That's amazing to have a weather event. This is a weather event, not a climate event, that had temperatures just spike just for a few days, way out of the average. It's unbelievable. And so this work is being worked on as we speak right now. We look forward to publishing on it in the near future. There was lots of media press about it. And one of the things I'd like to show you is how that behaved through time. One of the things we do in my research team here at the university is we build satellite composite imagery, which is what you're seeing here on one side of the screen. So that means we take every satellite, meteorological satellite that the world has to offer. You'll notice here on campus, the Space Science and Engineering Center has lots of satellite dishes. We're collecting everybody's data. It's great. Both polar orbiter, geostationary satellites, so the same kind you see on the TV, but the kind that fly overhead. And we put them together like a jigsaw puzzle over Antarctica. So here, I'm actually going to show you several weather stations reporting, and then you can see in particular in the red, their temperatures. And the cloud features here, by the way, Dome C or Dome C2 weather stations here, Eagle 4 is another weather station we have here. And you can see as time progresses in this little sequence, you see all these clouds streaming into the region. And at the peak, by the way, this is an infrared satellite picture. Everywhere where it's bright white, it's cold. So cold places are either the cold Antarctic continent or tall, high clouds that are cold. Places that are grayer are warmer, right? So you see the open ocean is gray. But notice how grayish it is over East Antarctica. Dome Concordia is a very tall location on the East Antarctic ice sheet. And so we see all this gray over it. It's because all these clouds are over it, and there's all kinds of air that is moved from over the South Indian Ocean into Antarctica. And it warmed the temperature up in a very, very short amount of time. It's just amazing. By the way, I love the swirl in the last picture I got here. And that's great. That's a nice little swirl. That's kind of cool. So our weather station that we have one at Dome C. We've had it there for many years, long before the French and Italians set up their permanent station. It has its highest temperature ever recorded at this time in March. So minus 9.4 Celsius, which is what, 15 degrees Fahrenheit. That might not sound very warm to you. But this is the highest temperature we've ever recorded here, ever. That's like me going up to you here in Madison and saying, we're going to have our highest temperature that we've ever recorded here in Madison at night in November. Sun's not up in March at this location. There's no sunshine here. There's purely air coming from off higher latitudes moving into Antarctica, some cloud influences, and it warmed the temperature up dramatically. So this is an amazing event. It was literally 6 standard deviations above the mean, which is tremendously significant. It's just amazing. So it's almost 79 degrees above the norm. It's an anomaly that large, above the normal. It's just insane. Our weather stations nearby also had extremely warm temperatures. D47, D10, Eagle 4 was 52 degrees warmer than normal. Some of them were 27 or 37 degrees warmer than normal. It's just an amazing event. My team went down to Antarctica last year and they grabbed some great photos. This one, it's hard to see, but there was a solar eclipse that took place that Antarctica happened to be near where it was going past. So it was only a partial event when my team was in the portion of Antarctica where my team was at McMurdo Station. However, in the west part of Antarctica, so that's the spot here where there's lots of stations all kind of glommed together near the peninsula. The actual main total eclipse went across there. I have a colleague in Chile, Rene Gerardo, who's been studying this. And it's interesting because his idea is that, and this is one of the weather stations that belongs to another group, went right over this. In fact, you can even see in this particular picture, at the time of the eclipse, you could barely see, you can see the moon's right in the way of the sun. It was a darker moment. He actually took into account how much incoming sunshine there would be at that peak place, which is all the tan colors you see here are all just the amount of incoming sunshine that you would get at this one location. You notice they all have a bite out of it at the tail end of the graph. You see these big bites out of it. When we put on top of it are actual weather station temperatures at a bunch of places around the continent. And you'll notice almost all of them in the blue, temperatures are moving along and all of a sudden, bloop, they dip down. Here's another dip down a little bit later. Here's another one a little bit later, about the same time. It's a little bit later, a little bit later. They all have a dip. They all cooled. Isn't it interesting? Solar eclipse, even in Antarctica, we will see an influence in the temperature measurement. And so this is very exciting work that we're working with our colleagues in Chile on, and we're excited about that. Oh, isn't this pretty? I made this years ago. The Antarctic continent's like way over here in the corner. But I love this swirl in this picture. I don't know if I'll ever be able to repeat this. It's a really gorgeous, huge storm in the ocean off the coast of Antarctica. And it just comes through really nicely in the view. As I mentioned, we spend time making these satellite composites, and then we animate them. I sometimes show these to scientists and they want to just put this in the corner and watch it all day long and skip whatever else they're doing. You see so much detail of what's going on here. You can see the storms as they go around the Antarctic continent. You can see a lot of the low clouds. And I know there's some artifacts because we don't have perfect coverage. There's a little gray blotch, unfortunately, because I don't want to include any old data. I don't want to include any synthetic data. And so therefore there's always a missing quadrant somewhere along the way. One of the reasons I bring this up, and I've got it highlighted here, you'll notice all those clouds under that red circle are moving directly out of the South Pacific into Antarctica, just like the case I just showed you. And so these massive clouds that are transporting right into Antarctica are having an influence. So gentlemen, my team spent some time studying what we call warming events in winter. So we focus just on winter time. That is, we call it austral winter, right? That's winter in the Southern Hemisphere when there's no sunshine. And he studied almost 16 years, in the, once again, June, July, August timeframe, using the weather stations to find out when do we see these big warming events. And by big, he meant something that's more than 30 degrees Celsius of change in 5 days or less. So that's over 54 degrees Fahrenheit of change. And no decreases less than 18 Fahrenheit or 10 degrees Celsius of change. And they happen in certain sectors of the continent. So this work's very exciting because, and here's, by the way, an example, there's a spot that warmed up in less than 4 days by 70 degrees Fahrenheit in winter. There's no sunshine here. Isn't that amazing? That's what our weather stations are capturing. It's just impressive. And we're trying to now learn about it. So this is one of the things he did for his master's degree. How often does it happen? So this is the variations through the years. We study different sectors of it, and we're studying some of the weather behavior you get. By the way, you'll look at the lower right picture, you'll see the actual temperature anomalies that go with these events. So where it's very bright red, it's warmer than normal. And significantly warmer than normal in some of these locations. And so that has an influence, especially if you're going to stress the Antarctic and the Antarctic ice sheet. Keeping it warmer than normal when it shouldn't be really has an influence. I've shown you lots of weather data here today. And one of the things we've been kind of quietly collecting, Dr. Stearns used to do this. He'd come to our office and he'd go, here's some data. Go put that out there so the world can get it. We now are really excited to be here at Wisconsin in collaboration with Madison College, an official repository. So please break out your smartphones, take a picture of the QR code here. It should work. We have a data repository, and this is like a formal one. So it's like a library of data, so it actually has digital object identifiers and follows the FAIR principles where you want the data to be findable and accessible, interoperable, reusable. And we want anyone to get at it, right? Whether you're a scientist, an educator, whatever. We've just put it out. It's just starting. It has a lot of our weather station data, and we'll be adding more things as we go because we collected data for like 4 years. And we only started this project in the last 2. So it kind of takes a while to get everything in there and make sure it's all what you want. So we're very excited to have this and be the official library, if you will, for Antarctic meteorological data. And if we won't hold the data, our plan is to also have links to somebody else who might worldwide. So that's our plan. If you ever want anything, we will hopefully, if we don't have it, we'll tell you where it is. Oops. A few scenes from the field. So yeah, we take some of these kinds of planes. There's the twin otter planes we were mentioning. They're two engine aircraft that get us around. I amaze myself that for someone who doesn't love to fly, I fly a lot of small aircraft all over the place in Antarctica, and it doesn't bug me. I have no idea why. Wildlife. There is a little bit. This is a skua. It's a lot like a seagull. And they're around in the area. Definitely protect your good. You know, if you're gonna be taking your lunch from the galley to your dorm, please make sure you cover it up because these guys would like to have it. Seals. Oh, there you go. They're around. There's a couple of spots in the pressure ridges nearby where they can come up through, and they're kind of around. And of course, as you just saw a preview of, we can't not have a discussion about Antarctica and not show you penguins, right? We must do this. This is a few nearby. We have a couple of weather stations nearby penguins. There's rookeries. And so they're, I know they look cute. They're very loud. And there's definitely an odor, so I'm told. But anyways, I don't usually get to see penguins myself when I deploy. A lot of our weather stations are quite a ways from where they're typically located. I forgot to double check with someone on these pictures, but you'll notice this penguin's off in the distance, and you notice they're a little ways from the ice edge. Can you tell me why these penguins might be kind of staying away from the ice edge?
They're not like landings.
Look closely. Look closely. Let's see. Yeah, whales. Yeah. One thing I wasn't sure if these were orcas or minkies. Minkies aren't really interested in penguins that much, but orcas would be. So it's interesting. We do once in a while have orca whale visit us outside McMurdo Station. And so it's quite the luxury to have that take place, to see them come by and breach right there. Minke whale, it's another different, I have to admit, this is where my expertise comes to an end. Another variety of whale, right? Yeah, but beyond that, I'm not sure of the details. I just noted we take all kinds of transportation methods. Helicopters. As noted, the LC-130 aircraft get us to places like South Pole Station or field camps in West Antarctica. And yes, we travel. And by the way, last night, the United States flew its first C-17 in for this season. Plane just like this just landed in Antarctica yesterday. And it was a bumpy ride, a little bit of icing, but they got in. It wasn't too cold, only minus 39, minus 40. That's good. If it's minus 50, it's a problem because they can't operate at that temperature. So that's really good. Once in a while, I get a great picture. This is one of my best selfies ever. I think I only got one other one that's this good. This is inside the twin otter aircraft. We were just visited a location. That's the gentleman in the red behind me is my colleague, Dave McGlyachek. And on the gal behind me is Sean. She was, we love to take folks with us who never get to leave McMurdo Station. We always need the help digging snow or helping us with things. She worked in laundry, and I was thrilled to have her come with us for the day. And she loved getting out of town. So we get to meet some fabulous people. I've even met people that I've never met before. And we're in line at the galley, and I find out the gentleman next to me lives on State Street here in town. You just never know who you're going to meet. But sometimes you meet some interesting folks. Does anyone know who this might be? Indeed it is. This is Edmund Hillary. Sir Ed comes to Antarctica every so often when he had the chance when he was alive. He loved going to Antarctica. He was ecstatic. This was just the year before he passed away. I flew out with him. They let him up in the cockpit of the C-17. Boy, that C-17 did things I didn't think it could do. I don't know what happened, but it flew around in kind of crazy ways. But it was lovely to have him out, and he had a big thrill going because for those who don't know, one of the things that Sir Ed's also known for besides climbing Everest is the first to drive across Antarctica in snow tractors. Does anyone know who this is by any chance? It's okay. This is Prince Albert of Monaco. I was thrilled to meet him. He was exhausted, poor gentleman. They had just, as Monaco as a country, when I met him on this trip, just signed the Antarctic Treaty. There's a treaty that reserves Antarctica for science. There's a lot of countries in the world that have agreed to it, and Monaco had finally agreed to it, which was lovely. And after they agreed to it, he said, I'm going on tour to see all of the stations there. And we were one of the last, the United States station, and we're very close, only a few kilometers from the New Zealand station. And I got the chance to meet him, and it was fun to have a few minutes conversation with him. Well, we must go. We've been here a while. I'll leave with a really great, isn't this a great photo? This is Mount Discovery out in the background here. It's a very, very tall dormant volcano. And when the air gets forced over it, it creates these saucer-like clouds, look like UFOs. They're called lenticular clouds. They look lovely, very laminar smooth, but I wouldn't want to fly an airplane through them because the wind is screaming fast through here to make it happen. So I'm going to stop here and thank a group of people who really make this work happen, aside from my team. The National Science Foundation, who oversees the Antarctic program by order of the president, pick your favorite from Eisenhower to Reagan, they all ordered it to happen through NSF. There are a lot of folks who support us. There's an Antarctic support contract group. There's a group of weather forecasters at McMurdo Weather, the Naval Information Warfare Center. The Air Force, right? The 109th Air Guard, the 62nd Air Force, Ken Bork Air, PHI, Kilos. All of these folks make what we do possible. And so we thank them all very much. And at this point, I'll stop and take any questions you may have. Thank you.
Bring the sound to you. Well, I remember one question out of 100 I had.
Excellent.
In your composite photo, it looked like all of the I guess air masses or whatever you call them, like they were converging, coming to the South Pole, and then maybe kind of like idly they kind of turned down.
Yes.
So is the atmosphere different there? Is it thicker because all this winds, atmosphere trying to push there, or is there just something unique about the atmosphere?
So what's happening on those composites is generally, on average, storms are going around the continent in the Southern Ocean. Those are the westerly winds, just like we have here in Madison, right? All of our storms are coming from the West Coast through Wisconsin toward the East Coast, on average. But as you noticed, that's not what's happening hour to hour, day to day, right? If I average them over a long period of time, that would be the case. But you're noticing some of the storms do hook into the Antarctic. So that means air is going into the Antarctic. And then when you push a lot of air into the Antarctic, air has to compensate for that air went into Antarctica, and then it pushes off. And so that's what you were probably noticing. I'm very impressed that you noticed that ebb and flow. And it's not that the air is thicker. It turns out the atmosphere is actually not as tall there. So the troposphere, where we live in, where we live, it's about 10 kilometers tall. Well, in the Arctic and Antarctic, it's actually shorter. The air is colder air is denser. It doesn't take up as much volume. It's actually like only about 9 kilometers tall or less. Isn't that interesting? But you are noticing that flow, that ebb and flow. You can actually see like air now, like kind of washing up on Antarctica and then kind of washing away. So well done.
Just wanted to mention, before I ask my question, it's Air Force 75th anniversary this year. And the question is, if you compared all those graphs regarding the temperature change, we also have graphs that actually show that CO2 emissions and what effect that actually has had on temperature in Antarctica. And with COVID happening 2 years ago, is there any like huge changes?
Right.
Compared to
Yeah, no, that's a good question. We've not actually looked at the atmospheric chemistry in our group. It's one thing I don't do a lot of atmospheric chemistry. However, it is being collected. So the United States has a group at South Pole Station. They collect bottles of air. I kid you not, literally bottles of air. And they stick a cork in it and they fly it out. And then they analyze it. And that's how we know how much carbon dioxide is in the air. Because anyone want to gander a guess what's upwind of South Pole Station? No. Thank goodness too, right? Because I always like to show my students, like there are 2 places in the world we monitor carbon dioxide: South Pole Station and Hawaii, in particular at Kilauea. What's happening at Kilauea? Oh, right. And where does carbon dioxide come from in the world? Anyone know some of our sources? One of them is volcanoes. And I'm like, oh my gosh, we're ruining the measurement, aren't we? We aren't, because The wind flow upwind of Hawaii is lots and lots and lots of empty Pacific. The carbon dioxide from the volcanoes goes downwind. So same at South Pole Station, there's actually a sector called clean air sector. Nobody's allowed in it. Well, I was for a while. We had a weather station there. And only people out there are those doing atmospheric sampling, and that's it. And they collect the air, and we actually get carbon dioxide measurements. I haven't done specifically looked at the latest trend. We know the trend's going up everywhere. So it would probably correlate fairly well, but I haven't actually done that analysis. Most of the current analysis with temperature and the carbon work is being done by those who are drilling in the ice, getting ice cores, because they can do temperature reconstruction and they're pulling bubbles of gas out of the ice. And they know how much carbon dioxide we had in the past because it's in a little bubble of ice. Isn't that interesting? Little air gas. So, but yeah, the modern record, as far as I know, is probably matching. We just haven't done that analysis in my team.
Yeah, two brief questions. First, is Christchurch, New Zealand, still the primary jumping off point for Antarctica? And also, you mentioned some of the treaties about no territorial claims on Antarctica, but despite that, having several countries that are relatively close to Antarctica, haven't they staked out claims of their own on the Antarctic continent? Thanks.
So great questions. Yes, the United States' main jump off point to McMurdo Station and then on to South Pole is Christchurch, New Zealand. It used to be actually a full-blown naval air station. It has now been converted to an International Antarctic Center, where the United States, the Italian and New Zealand Antarctic programs are based. The US still has a big hangar there. That's where all the flight operations takes place. And it's a joint effort between the New Zealand Defense Forces and the United States, which is run by, like I said, NSF with folks from the US Air Force and all that. When it's because it's no longer a Navy operation, it's an Air Force thing. It switched in 1999 to Air Force. So yes, there's your answer to that question. And then with regards to the treaties, correct. Lots of political claims have been made to the Antarctic by several nations. And you can pick a variety. New Zealand has, Australia has, Chile, Argentina, and some of them overlap. The United States hasn't made a claim. The United States has only reserved the right to make a claim. It hasn't done it. That's what's exciting about the Antarctic Treaty. In the 1950s, the scientists got together and did something very astute. They said, we're going to put off all the political claims. And while the treaty, the Antarctic Treaty exists, Antarctica is reserved for science. And it's really cool that we've set a continent aside for that. And so for now, everyone's work there is science. Yeah, it's not, I'm sure, I don't get to work that much in the treaty community, but I know that they meet routinely. There's a consultative meeting of all the different nations that participate in those activities, and it's been extended to include environmental protections, which wasn't thought about initially in the 1950s, 60s. Now it is, which is really great. We protect the flora and fauna of the continent as well.
Dylan, do we have anybody have more time? Okay. With these huge domes of warm air coming in, I've got the idea. You mentioned the air samples for, I'm assuming, chemical settlements. What kind of monitoring, if any, do you do for microbes that are blowing in the necessary way of being able to trace where these winds may have come from?
So I haven't done that, but I have heard of others who have. When they drill through the ice cores, some of them, probably the ones that most of us think of, are super deep, right? We're getting an ice core that goes down 3 kilometers or whatever, but not everyone does that. Some of them are doing shallow coring. And we used to get, in the past, people call us up, hi, we're seeing Patagonian dust in my ice core. How come? And it's because, oh yeah, you've literally lofted dust from the Patagonian desert in Argentina, and it's blown in and landed in the Antarctic, right? Now, there may indeed be the biological microbes in those ice core. I have to admit, I don't know the status of that science. If anyone's exploring it, they may be. That's a great question. I know that there's great interest in the fact that the Transantarctic Mountains, which kind of cut between East and West Antarctica, there are algal mats growing at elevation when the snow melts out a bit, I think as far south as like 80 degrees latitude south, which is amazingly far south, and have algal type things growing. It's impressive. So there is something happening or always been going on. I just don't know a lot about that science.
So that's for the ice core where the things may be deposited.
Yes.
So do people, are they taking daily weekly samples for microbes in the air?
Yeah. I don't know. That's a great question. I'm not sure. There may be some, but I'm not aware of it. It's a good question.
While I'm walking there was a page on one graph. It was an acoustic page.
Yeah.
Down. Can you tell us about it?
Sure. So we actually, and I didn't bring one with me today, I should have. We actually have off the side of the weather station, it basically sends a sound wave from the sensor to the snow surface, and then it reflects back up. So if you know the speed of sound, the temperature, which we do because we have a temperature sensor at the bottom of the tower, which you can correct for the speed of sound, we can calculate the distance from that sensor to the snow surface. And we do it for a couple of reasons. One, there's some glaciological folks who study ice that are interested in that accumulation rate. I'm interested because I want to know my weather station is getting buried, right? Because then it disappears. That's a problem. There has been discussion about whether or not we could estimate precipitation from it. There's been studies going on right now. Doesn't look great from my colleagues who've been spending time with a lot of high-tech toys in addition to something simple like that. But we find it an inexpensive, relatively speaking, gauge to give that measurement and be valuable for those who do care about just pure accumulation. I want to know if this is a place that has lots of accumulation or the opposite, ablation, right? Where snow is leaving the air.
How many countries are represented in research there? And are there weather stations and then other research stations? And what are the other research?
Yeah, absolutely. So I should go back to my map, right? Way back where the heck that was. The map that I had before, sorry, it was way back here, had lots and lots of stations from lots of other countries. That's why I wanted to go back. It's worth a quick gander at it. If I remember right, I'm trying to think, we had at least, so all the triangles in this map are Wisconsin weather stations, regardless of the color, right? The red ones we do, the ones that aren't red, we do with other nations, okay? So that's quite a few. So just to point out, it's all this big list on one side. The other two lists are all these other countries, right? That I'm aware of. So, 2, 4, 6, 8, 10, 12, 14, 16, 18, there were 20 countries doing weather stations of their own. Some only have 1 or 2. Some have 6 or 8. Nobody has a network of 60 like I do. But it's, some are growing, like China put in quite the line recently. They put in this big line here. We've been collaborating with Japan. In fact, I get to talk with those gentlemen tomorrow. I'm excited about that. I'm going to talk about what we're going to do next. France and ourselves have been jointly doing a line here for, 4 years. But in any case, yeah, there's quite a few who are, but it's a mix. So I'm sorry, was there another part to your question I missed?
What other sorts of research is done there besides weather?
Oh, yes. What are the sorts of research done besides weather? Okay, the answer is yes. You name it, they're doing it. It always impresses me when I go. I'm usually one of the few meteorologists at McMurdo Station when I'm there. There's not a bunch of us. There's very few, because a lot of Antarctic meteorology work is sometimes just done back here and not in the field. There are weather forecasters there. There's occasionally a group who's going off to do precipitation work or some other activity, but every other discipline's there. Everything from, what you would expect, folks who are doing biology work, which, by the way, biology and medicine, #1 Antarctic program in the United States. And it's hard not to think of that because they do cool stuff. I mean, it's not just the penguins and the fish, which, by the way, the fish are interesting because they produce antifreeze that prevents, because they're swimming around in ice water pretty much and they don't freeze. It's amazing. That's a whole study area. I remember one year I met a group of gentlemen who were diving to collect sponges growing at the bottom of the sound out in front of the station. And it turns out the sponges produced a chemical that made them toxic, so the fish wouldn't eat them. Guess what the chemical was an inspiration for? Chemotherapy drugs. cool. I mean, you know, the coolest stuff that you would never think of is happening there, right? And then it just goes on from there. Folks who are studying the seismology, the fact that as Antarctica slowly melts out, the continent is being weighted down by ice, right? It's kind of pushing it into the planet. Well, it's actually rebounding. It's coming out of the ice, and you can measure it. And there are people who spend time doing that, or studying volcanoes, right? And so the list is really long of all this other cool stuff that goes on. Space physics is done from down there, you know. NASA launches balloons with payloads on them because it's cheaper than launching a rocket. And so they'll do 2 or 3 of those a year if they can. So it's just amazing the stuff that goes on. So it's really, really highly disciplined, or a variety of disciplines.
We've got 2 questions on the Zoom. The first question, has there been any research into what, if any, effects the migration of the magnetic poles may have on the weather patterns?
Wow, I don't know that there has, at least not that I'm aware of. I've not looked into it myself, and I'd have to look into see if anyone else has looked into it. It's a good question. So sorry, I don't have a quick answer.
All right, and the second question, are there any possibility of deploying robots given the assumption they can withstand harsh conditions with advances in technology? Also, have you conducted any lab tests on penguins and seals to see any changes in them can be correlated with the abnormally high temperatures? So
the last question on the seals and the penguins, I haven't done that, but there are folks who have. I'm not sure of all their findings off the top of my head, but I know that they've been looking into it. I think some of their concern is how certain large phenomena, like there was some very big iceberg that calved off of Antarctica in the last 20 years. Anyone vaguely remember this? Maybe hitting the news? Okay, Tom remembers. That's excellent. And so some of those icebergs got in the way where penguins have their rookeries, their home. And when they try to get back to them and can't, certain penguin populations plummeted. It was hugely impactful. There are other studies going on by other folks that are relating climate change to the impact on penguin populations. I don't, like I said, it's not my study area, but I know that there are biologists who do that work. Now, for robots, interesting idea. Kind of we are, right? The weather station's a robot, it just doesn't move. And it's a very intriguing idea. The biggest advance we've seen in that area that I'm aware of is that we're now actually campaign using UAVs, right? Unmanned aerial vehicles, or unmanned some sort of aerial, device. And that's becoming very popular to study science in the Antarctic. And it's one of the things my compatriot that I work with, graduate from here, he's out at the University of Colorado. We've been flying it with weather sensors on board. With my tall tower weather station, the combination allows us to get a good understanding of the lowest environment part of the atmosphere and how it behaves, especially through time. So we're getting to that point of being able to do that kind of work. But a traditional, I don't know, we're not running a Roomba or an iRobot out there. Not yet. All right.
I was wondering about the time lost on these weather stations through damage or icing. How much of your maintenance time is spent just going around the area? And you lose when they're broken.
Yeah, it's unfortunate that we do run into, we want to observe in really rough places. And so you do lose time, or maybe I'll put it this way, we lose data, right? I'll give you an example. The pandemic has been very difficult for us. On this map, you'll see here in West Antarctica, 2 stations called Austin and Cathy in West Antarctica. We were supposed to visit them and we had already delayed seeing them. So that meant that they were probably short. They are in a high accumulation zone. So the acoustic depth gauges were only showing half a meter, or less. So we're talking 2-3 feet. We're worried they were only maybe 5 feet tall. And that was the year of the pandemic. And it was the first time we didn't deploy in 40 years. Someone from the University of Wisconsin has been deploying to Antarctica for 40 years straight to service some portion of this network. And so this is hard because this is a part of Antarctica that we really want those observations. so we can understand some really important things that go on, like how the climate is changing here, how things like El Nino are impacting this part of the continent. Both stations stopped operating, and we couldn't see them last year either. The situation turned out that we couldn't go, and now they're off the air, and we suspect they are buried. So we might not be really able to find them. So we're going to have to put up brand new stations. So there's an extreme example of the loss, right? I've got a 2-year gap of data, and now I have to put out another station, which is expensive. Not as expensive as to fly south there, by the way, right? It's not cheap for us to go to this place. So we try to limit the amount of times we have to go for that reason. So those are some of the costs. Otherwise, repair time, we are on the ground 4 hours. We can pull a station apart, get it reassembled, 4 hours. Typically, that's about all we might have for ground time, because it may take us 3 or 4 hours to go to a weather station site. You know, this area here of Antarctica where all these stations are clumped together, the Ross Ice Shelf, that's the size of Texas. So we have to get up, fly across Texas, fix a weather station for 4 hours, and fly back across Texas to be back in town before the cruise air day ends, right? Because they can't be flying for too long, right? So those are some of the challenges we have in that. Great question.
You idle planes.
Heck no. That's why we go in lovely weather, right? For the Twin Otter aircraft, no. For helicopters, sometimes we have close support, which means the helicopter lands and stays there with us. Sometimes they say, okay, we're leaving you here. Here's a radio. Good luck. No, we do a radio check. We make sure it's okay. I mean, we're only helicoptering to sites. See this inset here? This is close to McMurdo Station. We're only flying to these weather stations here with helicopters. So we're within radio communications of the main US station all the time if we need to. So we might do that on occasion, not have the helicopter leave and come back and get us later. But otherwise, no. The places that the planes stay running all the time when they land at South Pole Station. So these 2 stations we have here are 100 kilometers near South Pole. So South Pole's right at the tip of that arrow. So when the Air National Guard lands there, planes always get its engines on, and then it leaves. They do fly those same aircraft out to West Antarctica too. They prefer not to turn them off. They've had to at times because, well, if the plane broke, you have to turn it off and fix it, and then you can fly out. And the other thing that they don't do is the C-17s. They won't turn those off either. They literally fly in, people get off, cargo gets off, cargo goes back on, people go back on, and it leaves all in the same day, pretty much. So, and especially when it's really cold out like it is right now, when they did their flight yesterday, did the same thing.
So I'm kind of curious. I have 2 questions. I know Antarctica expands and contracts. So like in the last 40 years, how much of a change has that happened? The other question is, if all the ice was actually melted off of Antarctica, how much landmass would actually be left?
Okay, so the expand contract idea is generally thinking about, I wonder, we should go look at my composites for a minute. They're fun to watch. We should put up animations of that. What you're thinking of is the sea ice around Antarctica. That sea ice actually makes Antarctica grow if you want to count the sea ice around it as a part of the continent. So here, Antarctica is inside the red, right? But the sea ice actually grows all the way around it out and away. This particular animation, it's taken in a time frame that won't have a lot of it in it. Also, you see more clouds in the actual sea ice. So that's what you may be thinking of the shrinking and growing. Is it literally almost, well, it doesn't quite double in size, but close every winter, right? And then it decreases every summer. And that's one of the things that's been awkward too, is the way that sea ice has been behaving is like in the Arctic, we all know we're losing sea ice, right? That's 2007 to present, other than a few exceptions, it's just less and less and less and less and less. Antarctica has behaved weirdly. We've had some periods when it's had more, and now we're starting to see less. Some of that is tied up with other strange phenomena, like, oh yeah, we're finally fixing the ozone hole, right? Everyone heard of, where's the ozone hole? Anyone? Yeah, a few of us heard of that, right? It's really a thinning, it's not a hole, but we're recovering. It's a lovely thing. Our grandchildren are going to be able to grow up in a world where we have one again. It's that we actually have ozone again in the stratosphere. It's lovely, but it has some strange consequences for the atmosphere below. But now we're starting to see the sea ice change there, which may once again be related to, it's a study area. We're learning about that. So that's the deal with the growing and shrinking. Your second question was,
If all the ice was gone.
Oh,
how big
all of it
the
melted.
should be.
yeah, well, I hope you don't have any real estate in Florida. The coast of any coastal region in the world is in trouble. There are maps where it's tens of feet of sea level rise. It's massive if you melted it all out, because massive parts of Antarctica, it's ice on top of land. So as it melts, it would contribute to sea level rise, right? The ice shelves don't. So these floating areas like the Ross Ice Shelf I mentioned here, this big, I got my cursor over here showing it, that's a massive floating ice shelf. If that melts today, doesn't contribute to sea level rise. And if don't believe me, try it out at home. Get a glass of water, put one ice cube in it, mark the level, and as the ice cube melts, the level will be the same because the ice is already displacing the same amount of water. Have you? Does it work with gin? I didn't know. It's the rest of the continent that's the problem, is that all of this big, tall amounts of ice. I mean, East Antarctica here, there are places here that are 4 kilometers of ice. It's a lot. And right now, the United States and the United Kingdom are studying this place out here in West Antarctica called Pine Island Bay, Thwaites Glacier in particular. It's a test case of how the system might be reacting. And there's a reasonable understanding. So far, we're halfway through the research project that we're losing ice, and perhaps a lot of it. And so that will all contribute to sea level rise, slowly but surely. Yes.
Who says Thwaites Glacier?
Oh, you caught me without remembering. I knew there was something I wasn't going to be able to answer that I should know, and I don't. But it is named for someone, isn't it? Yep.
Yeah.
I think he might be.
But I don't know how big is it?
What, the landmass of?
Where? I don't know.
Oh, so this area here, right, is this continental size of what? Continental US and Mexico combined. It's huge. So, and then the actual amount of, so if you melted it all, right, because it is tall, it would add, I can't remember if it was 65 feet or 100 feet. There's a very large number that is massive amount of sea level rise that you get. Sorry, I don't have that number off the top of my head, but it's quite a bit. And it would have huge influences because when you spread that out over the oceans, coastal locations are very susceptible. And it's where most of our population in the world lives. They would all be at risk. There are places that are better on the world to be. Well done. You live in Madison, Wisconsin. We would do okay. But it's harder in other places, right? And we're starting to see the impacts of that in certain places are noticing sea level erosion. Hurricane Sandy was a big hit to the US, realizing, oh, we can flood in the subway in New York City. That hasn't happened before. You know, all of a sudden some stuff is starting to come up that we've noticed. So, yes.
I didn't mind from anybody, but it was great to think about this question about ice on the continent, which I would assume the whole rest of the world would have to see it. What would, is there much of a land that's exposed that people could study?
Oh, yeah.
What if the whole exposure of that continent, I mean, what would completely fine?
Yeah, no, I've always wondered about that too. And I've seen some depictions of what it might be like. As it turns out, West Antarctica is actually mostly would be below the sea level, believe it or not, once it all melted away. It's not all above sea level. Although one thing that's interesting is understanding, well, now that there's no more heavy ice pushing the continent down into the crust of the earth, how much of it would come up out of it, right? And that's a research question, right? Because that would be happening as well. You don't have this big heavy thing pushing it in, so it would pop up. But under East Antarctica, you know, there are buried mountain chains. You can't even see the tops. They're just buried totally in ice. The Gambertov mountain chains is totally buried. There was a huge project the United States did from the aerial geospatial folks that love flying airplanes to map out things underneath the ice and learn about things. And they called it this project, this Antarctic, I can't remember what the acronym stood for, but it's AGAP project. And they found a huge mountain chain buried out there. And so there is a lot of land, especially in East Antarctica, that would definitely be exposed. You would definitely see it.
Okay, I had a question, a couple of questions here.
Sure.
How much redundancy of the sensors do you have at each station, or are they just basically single?
Excellent question. So with the new project, the PCWS project, we're no longer going to have just single temperature sensors at the stations. In fact, inside this shield, we're gonna have 3. And the idea is to be able to know with confidence that we understand that temperature value. We will be measuring temperature at 2 levels on the station for sure. So we have one at 0.5 meter off the snow surface, and this with the top, which is about 3 meters. We'll probably only have 1 wind system. They're expensive, to do these wind systems, and then probably 1 relative humidity measure. What we are adding more. So we talked about the acoustic depth gauge, but we're also might try out incoming and outgoing sunshine, and then the amount of energy the Earth radiates away, or the amount of energy the atmosphere radiates down. Those sensors are extremely expensive, and they may or may not work well because they get frosty or dirty. They don't measure great, but we're going to try it out. So that's a sophisticated set for a system that we're going to leave out there all by itself.
The other question you had sort of correlates with this. You're building your own electronic systems, and are you just doing standard military spec considering that, or are you doing better compatibility?
So when we built the new PCWS system, we said, okay, what can we buy commercial off the shelf, even though it's not spec'd to work below -40 Celsius or Fahrenheit, same value. We put it into a freezer. So we bought a -85°C freezer and we tried it and said, does this run? And we found some that are commercial off the shelf that do, even though they're not specified for it, and said, okay, if this will run, then let's build something around that. So we found some systems for that. So the one thing we are doing is that we're not changing the sensor sets or building new sensors. We already know what works really, really well for those. And so the platinum resistance thermometers, some of these wind systems, this is a very standard RN arrow vane. This is a really classic thing. This works great. Even at high wind speed, we notice it's not shattered. I have in here this box, a relative humidity detector. This is kind of nice because this one will actually run really well in the cold. It actually runs below most everything quits at -40 for electronics. Most manufacturers won't certify anything below that. This actually goes to like -50. It's pretty good. And we know it even does better than that. I will check that out. We do use a really, really high-end pressure gauge, but we don't manufacture those. We already know what goes through there. It's the electronics core that collects from these that we were worried about. And so that's why we said, because they're the community that builds those, they build them for everywhere in the world. And that's great for a lot of other places, but for here, we wanted something that we could be confident in. So that's what we did.
One last question here.
Sure.
Probably, I don't know if you answered correctly. With all the weather anomaly that you have with the data and everything like that, what data analysis, or I assume you've done some, that you correlated between precursor or postcursor to world weather events?
Oh, interesting. I'll give you an example. Everyone heard of the big Tonga volcanic eruption? Yeah. So I was very excited that our Japanese colleagues we shared that was weather stations with, they also have a set nearby. The pressure wave from the Tonga eruption, we saw it in the weather station data. You could see the actual jump. And when the wave went around the world and it came back around, we saw the next jump. Isn't that interesting? You really could. So there is a connection, things like that we do see. So yeah, everything's connected to everything else. And there's an example of that. Yeah.
Well, 6:25, really appreciate all of you. Thank you very much.
Thank you.